Okay, hello everyone. I am not seeing any questions. Hopefully you can hear me. But if there aren't any questions, I just wanted to go over these helpful rules of thumb, specifically for Chapter 9, and then some of the practice exam questions, which I think would be helpful. If you do have a question, feel free to ask it over there in that live chat. I know there is a little bit of a delay, or at least there was last time I did a live stream. So if you have a question, or just send it over and then wait about 20 seconds. All right, so here's a helpful rules of thumb. Sometimes it's difficult to find what the null hypothesis is or what the alternative hypothesis is. Sometimes if you're looking at a situation, one can be easier to find than the other. So these are kind of two questions that you can ask yourself. So you can either ask yourself, what is the status quo or what is the current situation? And then the alternative hypothesis is, what are we trying to prove? So also keep in mind that your null hypothesis always has an equal sign, a less than or equal sign, or a greater than or equal sign, and only those three options. And then your alternative hypothesis is going to have a not equal to sign, a less than sign, or a greater than sign. So again, that's going to be the only three options for those alternative and for the alternative hypothesis. So your critical value, your critical value tells you when that's too far from your null, right? So you're trying to find the probability that you would get this result given that the null is true. And that critical value tells you when, okay, we're too far out into the tails. So if your t statistic is within the region of rejection, then you reject that null. So let me just draw that out for you. So, for example, say our null hypothesis is that the mean age is 50. Your critical value tells you, when we should reject our null. So say we collect a sample and we get that the average age is 20. Well, what's the probability that we would get 20 given that our null is true or that the population average age is 50? So your critical value tells you when you think that's too far. And you would want to calculate your t statistic for this. For this class, we don't need to calculate anything. But if I were to tell you, say your t value, your t critical value is plus or minus 1.64, and your t statistic comes out to be negative 1.4, then that's in that region of rejection. So here's my critical value of 1.64. My t statistic is negative 1.4. It'll be somewhere over here. And you can reject the null. If it's not within the region of rejection, so if it's in this middle part here, then you do not reject the null. I always like to draw these out. Sometimes it's difficult to picture where negative 1.4 is in comparison to 1.64. Your p-value is related to this. So your p-value is the probability. Remember in our last unit when we are finding the probability under the curve? Well, we are basically getting you ready for the null hypothesis testing. So you have your t critical value, your t statistic, your p-value corresponds to the probability under the curve. So if your probability is less than your error, your type 1 error, which is chosen by you as a statistician, then you reject the null. And if it's greater than your alpha, then you do not reject the null. For those conclusions, so if you reject the null, then you have sufficient evidence to say the null is not true. And if you do not reject the null, you have insufficient evidence to say that the null is not true. So the reason that we are only comparing it to the null and whether it's true or not is because we're using conditional probability, right? What's the probability that we would get this result given that the null is true? Well, we have evidence to say that the null is not true, or we have insufficient evidence to say that the null is not true. Okay, your alpha is your type 1 error rate. Again, that's chosen by you. So if you want to be wrong, 10% of the time or 5% of the time, that's up to you. Industry standard is 5% though. So your type 1 error is deciding to reject the null when it is actually true. It's known as a false alarm, or saying something is there when there really isn't something there. So for example, a doctor telling a woman is pregnant when she is not would be a type 1 error. Type 2 error, on the other hand, is deciding not to reject the null when it is actually false. So it's a missed opportunity, or saying something that is not there when it actually is there, or a doctor telling a woman she is not pregnant when she really is. And then you can have two instances where you do have correct decisions. So you can decide to reject the null when the null is actually false, or you can decide not to reject the null when the null is actually true. Okay, so still don't see any questions. So I'm just going to go over these chapter 9 questions over here. Let's see, starting with 38. So this is from the practice exam. Okay, so which of the following would be an appropriate null hypothesis? So remember, going back to those tips and tricks. Your null hypothesis is always going to have an equal sign, less than or equal sign, or greater than to equal sign. So the mean of a population is less than 40. That is more in line with the alternative hypothesis. The mean of a sample is equal to 40, or the mean of a population is equal to 40. So the other thing about null and alternative hypotheses is that it's always going to correspond to a population parameter rather than a sample statistic. So it's definitely not going to be B, because this is pertaining to a sample. It's not going to be A because it's not one of our signs. And the population is equal to 40. This is why C is going to be a good answer. Okay, if the test of hypothesis has an alpha of 0.01, it means that, so remember, your alpha of 0.01 is your type 1 error. So if the null hypothesis is true, you don't reject it 1% of the time. If the null hypothesis is true, you reject it 1% of the time. If the null hypothesis is false, you don't reject it 1% of the time. Or if the null hypothesis is false, you reject it 1% of the time. So remember that type 1 error is saying something there when there really isn't something, or saying that the null is false when it really is true. So in this case, B is the correct answer. If the null hypothesis is true, you would reject it 1% of the time. Okay, number 40. Suppose we wish to test whether the null is less than or equal to 80, and the alternative hypothesis is that the mean is greater than 80. What will result if we conclude that the mean is greater than 80 when the true value is really 84? So the true value is really 84, and we have decided that the mean is greater than 80. That's a correct decision. If it's actually greater than 80, and I say that it's greater than 80, then that's a correct decision. Okay, so number 41. How many toilet paper sheets should Johnson's Company have on a single roll of toilet paper? Researchers determined that 1,000 sheets of paper is the mean number of sheets used during a week for a family of 4. Suppose a random sample of 100 families yielded a mean of 1090 sheets with a standard deviation of 22 used during 1 week. Give the null and alternative hypotheses to determine if the number of sheets in use during a week is greater than 1,000. Okay, so right off the bat, you can eliminate 2 of these options. Remember that your null and alternative hypotheses refer to population parameters rather than sample statistics. And anything with the Greek letter is going to be a population parameter. Anything with just the regular X or a P is going to be that sample statistic. So C and D are off the, they're not going to be options because these are talking about samples. A and B are talking about parameters. So that is why the only options that we have left are A and B. Okay, now going back to those questions, sometimes one is easier to find than the other. In this case, what are we trying to prove, or what are we trying to determine? Here it says we're trying to determine if the number of sheets during a week is greater than 1,000. So that becomes our alternative hypothesis. That's what we're trying to determine. So the mean is greater than 1,000. And then to find the null, you just take the opposite so that the mean is less than or equal to 1,000. Okay. Still no questions over here? All right. So number 42, suppose that the test statistic falls in the region of rejection at an alpha level of 0.05. Which of the following is the correct decision? Okay, so remember, if a test statistic falls in the region of rejection, you're going to reject the null. So now we're left with B and D. And we use an alpha of 0.05 as it states here, so the correct answer is B. Okay, referring to the scenario in 41 and 42, which of the following conclusions is correct? Okay, so remember that if you reject the null, let's go back to those rules. If you reject the null, you have sufficient evidence to say that the null is not true. So we have sufficient evidence. B and D are both sufficient evidence. There is not sufficient evidence, or there's insufficient evidence. That would be if we did not reject the null. So we have sufficient evidence where that B or D, that the null is not true. Here we have the mean number of sheets is 1,000, or the mean number of sheets is not 1,000. So the answer here is going to be D. Okay, 44, you've created a 95% confidence interval for the mean with the result of 20 to 30. What decision will you make if we test that the mean is equal to 32 as a null hypothesis, and that the alternative is that the mean is not equal to 32 at an alpha level of 0.1? Well, we have a 95% confidence interval. It does not include 32, so we can just reject the null. So if, for example, we are testing if the mean is equal to 25, then we would not be able to reject the null. We would do not reject the null. But because 32 is outside of our confidence interval, we're going to reject the null. Okay, the owner of a sandwich shop recently surveyed a random sample of 250 customers in the store. She would like to determine whether the mean age of customers is less than 40. If not, or if so, she plans to alter the advertisements to appeal to a younger crowd. If not, marketing will change. Suppose she found that the mean was 38.1 with a standard deviation of 4 years, and suppose that the p-value associated with this test is 0.078. At an alpha level of 0.05, what should she conclude? Okay, so going back to our rules here, what do we do when is our we will reject the null when your alpha is less if your p-value is less than your alpha, but if your alpha is less than your p-value is greater than your alpha, then you do not reject the null. So in this case, our p-value is greater than our alpha. So therefore, we are not going to reject the null. And when we do not reject the null, we have insufficient evidence that the null is not true. So process of elimination here, we have insufficient evidence. Whoops. Okay, please don't start updating. Uh-oh. Okay. We have insufficient evidence. So now we're left with B and D. And then remember, we have insufficient evidence that the null is not true. So the mean age is not less than 40. And the answer is B there. Okay, 46. All right, so the coordinator of an MBA program claimed that the entering class has a lower GMAT than previous years. He took a sample of 50 and found that their mean GMAT score was 550 with standard deviation of 73. The university record indicates that the mean GMAT score last year was 560. He wants to find out if his claim is supported by the evidence at a 5% significance level. So what is the null and alternative hypothesis? Okay, so he is saying that the mean is lower than last year's, right? That's what he's trying to prove or he's trying to claim. So now we're looking for an alternative hypothesis that says that the mean is less than 560. And looks like the only one where the alternative says that the mean is less than 560 is A. Why is it not 550? Well, 550 is, that's what we have. That's our current sample statistic. 560 is that status quo. So you could have asked, well, what is the status quo in this case? Well, the mean was 560 last year. Okay, 47 says, which of the following describes a type 1 error? So remember, a type 1 error is saying something is there when it really isn't. So the coordinator concludes that the mean GMAT score of entering students is lower than previous years when it is actually not lower. So saying something's there when it's not. That seems about right, but let's check these anyway. The coordinator concludes that the mean score of students is lower than previous years when it is actually lower. That's a correct decision. The coordinator concludes that the mean GMAT score of entering students is not lower than previous years when it actually is not lower. That's actually a correct decision as well. And the coordinator concludes that the score of entering students is not lower than previous years when it is actually lower. So that's a type 2 error, saying something's not there when it actually is. Okay, and that just answered our next question. So what's a type 2 error? That's D here. And then referring to the scenario in 46, if you select a sample of 25 and are willing to have a level of significance of 0.05, the probability of a type 1 error is, so your level of significance is also known as your alpha, which is also known as your type 1 error, your probability of type 1 error. So it's going to be 0.05. And then referring to 46, going back up here, if the critical value used to determine the region of rejection is negative 1.5561 and the test statistic results in a value of negative 1.4, we would not reject the null. So if you were to draw this out, our region of rejection is negative 1.556. And our test statistic ends up being negative 1.4. So that is not in the region of rejection, which would be that tail end. So we are not going to reject the null. Okay, guys, I still don't see any questions, but I will have another live stream on Thursday in case you still have more questions. All right, have a great night.